Hi everyone. So far I have been using Cubit software to do quantity tech cop and cost estimating for a simple building and fit out projects, but I haven't used it to do the cost estimating for an infrastructure because I know the software is designed specifically for building projects. But this time I want to try, I want to challenge to use this software to take up quantity for biocap, bioseed. And my intention is to make the length of the video is less than 25 minutes. But infrastructure is somewhat difficult to redrawing. So the video length may be more than 25 minutes. So in the next video, we'll try to cut short so that we don't feel boring when watching this kind of video. The quantity for the power cap, we will analyze the design drawing for this. So here in the plan, we can see the bio cap inside here, and this is section 1. From section 1 we can infer the height of the bio cap, and this is section 2, from here to here, which we can see the technique of the bio cap 2550. And another important thing I should mention here is that this design drawings, they are using a biosheet to act as a framework for this biocap. So in on site, they don't have to install a framework, but install a concrete biosheet and then pouring the concrete inside that to form the biocap. This software I already uploaded the design drawing for the biocap. In here we can see the biocap page 2, and another drawing is biocap page 4, in which uh, provide the design for the biosheet, the skin of the biocap. As I mentioned before, we will use this drawing to do the measuring for this biocap. On this software, Cubit software only made a PQ for this simple biocap project. We can see here the 2550 thick biocap contribute 55 megapascal and 100 thick base biocap for biocap cell and 150 thick vertical biocap cell and 200 thick cut in situ concrete 55 MPa. That's the concrete at the bottom of the biocap. Yeah, and the last item is exiting 150 centimeter distance for reinforcement rebar here. The biocap concrete. I will choose item and change the volume depth to 2550. You can see here the depth 2550, and then I choose the polyline and color, change color if we want, and then I will start measuring. It's like AutoCAD, but I will click mouse click and left mouse click, but this time I will hold the left mouse and then move to the exact position and then release the mouse. After that, I will click here, do the same. Okay. And then right click, it will automatically close the polyline and the quantity will populate it here. Don't forget to make deduction for the three pile occupy here 1 2 3. To do that, we will click the item and then we will tick to deduction and then we change the description to deduction bio deduction, and then we can change our light color here to red, and then to the clip ellipse one ellipse, and then in here we move the cursor and do the same. Move the cursor. Last one. Left click and then finish. We can see the bio deduction here, but don't forget now they are using the thickness of 2550 is not the right answer. We can see here only 50 mm thickness of the pile occupy inside the pile cap, so we will change that thickness. In here we will click the item pile deduction here at the calculation sheet, click the pile deduction in here at the detail we change the depth to 50. You can see now we change 50. Repeat the process for the other pile reduction 50 and 50. Yeah, now we can see only made reduction from this pile occupation. We move to the pile cap style, the skin of the pile cap. I will change to the drawing for the pile cell. In here we can see the drawing of pile cell here. Pile cells is the skin cover outside the pile cap to add a framework as I described earlier. So we'll choose the item here and choose the result tab. That is now we are measuring the base, so I will choose the volume and change this one. The thickness of the pile cell here is 250 for wall and same for the base, so I will change the volume depth to 250. Then I change the description to base cell base shell, and then I start measuring, but this time I choose polyline in here. I do the same process. I will click here. I click the outer of this drawing, not the inner. Here is very intelligent to infer what we are going to do. Yeah, and right click to close. You can see here the quantity already populated here, but with a negative amount because we still hear the deduction here. We need to change. Uh, Although we add this deduction here, it doesn't affect. So I will choose the item here, and then to calculation sheet, I click the last item, and then and this one very important. And this will be a positive one again. Yeah, the deduction for the 3 pile cap occupy in this area. We can review the step 10. We already make deduction earlier in the pile cap. Instead of redrawing the pile cap occupation, to do that we will click to item, and in the item bioconcrete here we will drag and drop here the first one and the second one and last one. It's same. Actually it's the same. We can use factor 3, but I didn't do that, so we will look into this if we have to do anything like this in the future. In here we will change our thickness is not 50 but 200. All right, 200 here, 200 and 200 and 200. Okay, we will measure the quantity for 150 mm for vertical pile cap. The vertical pile cap in this drawing is this area here. In the blend is from run along the perimeter of this plane. So for result tab, I will choose the vertical area and will change the description of step pane to vertical shell, and the volume depth is 150. Let's see, 250. 250 here. 250. Okay. But the height of this pile cap cell is 250 to 550. I will change here to 2550. Okay, because the result tab is tab is vertical area, so only the high factor will affect the result tab, while the volume tab won't uh, affect anything. I can do draw the area, but I don't do that. I will utilize the previous tab pane in the pile cap concrete here, here, pile cap, calculation sheet, and then I will choose this tab pane. This tab pane, the first one we haven't made deduction in direct and drop here. Okay, we can see the quantity for the vertical bio cap, vertical quantity only populated here 66 square meter, but we have to convert to cubic meter, or we can use the square meter because we can convert our unit rate, so we don't need to convert to cubic meter, just maintain the square meter. 200 mm thick cast in situ concrete. The bottom concrete here, initial cast in situ 200 mm is the concrete part at the bottom of the bio cap, but inside the bio cell. To do that, we will use the result tab first, use volume, and we will reuse the step pane of the previous calculation. Okay, here direct and the rope. It cannot be 110 cubic meter for 200 mm thick, so we will amend it. Click to item and click to the calculation sheet here, and click to the item 1 here and change the depth to 200. Okay, we can see the quantity now changed to 9 cubic meter, and we don't forget to make reduction for the 3 pile cap, the pile occupation here. So to do that, we do the same. We will drag and drop, drag in the rope, drag in the rope, and drag and drop. Okay, and click to item again to change the technique. This one change to 200 mm. Same 200 mm. 200 mm. Why 200 mm? Because the pile occupy here, from here to here, technique is 200 mm. The 150 centimeters distance here, and 16 bar coupler at 100 centimeters around perimeter. We will use our result tab, length by center, and then I will change the description to existing rebar, and it's very important to change the spacing here 150. Okay, and then click to item and the polyline. We change color to green, blue, and start measuring on the blend. Click here, left click, and then hold, release, do the same, hold, release, and right click to close the polyline. We can see the length already calculated here, 321 meter, and the exiting, we want to change this the from the linear meter to ton. To that, we want to know what is the kilogram per meter of exiting. Check this. I click to constant here, and sitting, the value is 1/6 by 1/6 1A kilogram per meter run. I will use it to the faster here. 1/6.1 1/6 1A divide, I want to change the ton, so divide to 1000. Okay, invalid 1/6 1A. Okay, we change to kg. I actually can add in a factor here, the column chooser, to add a factor here, but I didn't do that. And then this is one direction. To do the another direction, we can see the report we measured for the perpendicular, for the parallel direction only. Now we will calculate the perpendicular direction for the report. To do that, we just copy from calculation, click copy, then paste, and then click to the item we have just pasted, and in detail at the orientation change to perpendicular, and we'll see now it change to perpendicular direction, and calculate the quantity of report for us. And that's what I want to say, how to calculate a power cap for a bridge. Thank you for watching the video.